Hello, dear students. I am Dr. Kapil Chaturvedi, Associate Professor in Department of Computer Science and Engineering, Sagar Institute of Research and Technology, Sage Group, Bhopal. This is our first lecture of software engineering, and in this we will discuss the fundamentals, concept of software engineering. We'll also discuss what is software engineering and what is software engineers, and where software engineering will be useful for the software engineers, and what is the fundamental concept of it, along with the fundamental definition. So as this is our first lecture, so we'll have to understand what is actually software engineering. And as you know very well that you all are the software engineers. So you know very well that what is software engineers. So as the formal definition of software engineering, the software engineering is an engineering approach on a software development of systematic applications. The thing which we have to keep in mind, the software implementation is not a random process. It's a process which is well defined and well systematic process. So here we are saying that the software engineering approach on a software development of systematic applications. So what kind of and why we are saying that this is the sequential process? What kind of sequence we have to follow, we will discuss in this lecture. Now, what is software engineer? A software engineer is a person who applies the principles of software engineering to design, develop, maintain, test, and evaluate computer software. So the meaning of software engineering just not that you are you have a bachelor of engineering degree, you have a BTech degree, and you know very well about programming and programming concept. Your logics is very good, and you can implement any kind of a module by using the software. You can implement any kind of algorithm using the code. So we cannot say that you are the engineer by developing just a short program or just make a code. The task of software engineer is to follow a well-known, well-defined process and adopt a well-known model to adopt a system, to develop a system. So that we are saying here, a software engineer is a person who applies the principles of software engineering to design, develop, maintain, test, and evaluate computer software. So these are the steps which are very important from the software engineering's point of views, because whenever we start any of the project, the first question in our mind will be how we have to start the project. So on such time, we should have the information about the software models. We should know about the SDLC process. We know about the software development life cycle. So to develop any kind of software, we'll have to follow that life cycle. Life cycle, it means we'll have to follow a step-by-step procedure to complete the software project. So what kind of steps we have to adopt? First of all, you have to gather the requirements. It means you must know what is the requirement of the project, and that step is known as requirement analysis or need of recognition. What is the need to develop that software? So here requirement analysis will be carried out. This is the phase where requirement analysis will be carried out. Also the analysis phase will be the perform, where we will try to understand, try to learn what is the actual process which we have to develop. On the basis of that analysis, you will have to make proper designs. Simply you can develop a flow chart, you can develop a data flow diagram. You may also develop a simple framework where you can demonstrate what will be the process of your process, of what will be the step by step process of processing your data or information in your software. So, or simply, what will be the flow of the project? So we'll have to design all that, and also we'll have to design what will be the database structure, what kind of fields we have to keep, what kind of relations, what kind of entity, what kind of attributes, what kind of mappings we will have to develop in our database system or in our backend. And at last, we will have to develop what kind of our front view, where end user will be connect. So these all things will be designed in this phase, design phase. Then we will come on the implementation phase. In simple, whenever we have to implement simple code, we will have to implement a factorials program, area of circles program. This is also so small projects. But what do? We just sit on computer and start writing has include, I use stream, void man, variable declaration, and write the logics. This is not the way of implementation of the project. The way should be, first of all, we will have to understand how we will calculate the factorial, and we'll have to make a proper blue print on the on page. We'll have to make proper scratch to calculate a factorial. Then we'll have to develop the logic of it, and then we will have come on the system and start developing that program by making the code in C, C++, Java, Python, whatever you have to develop that code. This is the implementation. So on the basis of that design, we'll have to implement our code. We'll have to write actual source code. Once we complete our source code, we'll go on testing phase, where we have to check our logics, the outputs is proper or not, or different kind of testings we will apply. We'll apply different kind of test cases to check if the output is okay or not. We develop a required software or not. Sometimes client check that software by simply run that software and by feed the actual data in this. So different kind of testing mechanism we will apply on this in this phase. And sometimes when we apply the testing and when end user use that software, and if he or she face some complications, or he requires some modifications, they suggest again, and we will go on the evaluation model and go on the requirement analysis, because if they are suggesting us they require some more modifications in the software, then we will again analyze about that features which customer want, and will make analysis, again design that sort module, and will implement and test, and we will add that simple module in the existing software. So this is a whole process is known as SDLC. And the standard SDLC model says that we'll have to follow, first of all, we will first have to work on the requirement analysis, then we have to create design, then implementation, verification, and maintenance. We'll discuss in the last lecture in detail the SDLC steps. That lecture is the overview lecture. We will have to understand what is software engineering. So here we discuss the SDLC's overview, and then we are seeing simply the actual steps of software SDLC, major steps, major phases of the SDLC. Now we are coming on the software models. I'm just giving in this lecture the overview of the software models. We will discuss these models in the next classes. What is model? As we discussed in the very first slide, the software process is a step-by-step process. We will have to adopt some model to develop a software. So software model are way of expressing a software design, usually some sort of abstract language or of pictures are used to express the software design. So this definition simply says that we will follow a predefined model, pictorial representations, or diagrams to develop our software. So what kind of that model will be? So like this. The very first model is waterfall model, where we are seeing that we That model says something. The name of that model is waterfall. So that functioning is also as per waterfall. As we know that the feature of water, fundamental feature of waterfall is that always water will become from top to down, and once the water comes down, that will never go up. That will never go up. Once water will come from top to bottom from the waterfall, that will never go back. So similarly, if we have to come on the system design phase, first of all, we will have to complete the requirement analysis phase. Then we'll come on the design phase. Once we realize that design phase is complete, then we'll come on the implementation phase, then we'll come on the testing phase, then we'll come on the deployment phase, and then we'll come on the maintenance phase. So that simply that model says that we'll have to follow that process. But here we have to keep in mind, we'll have to completely complete one process, then we will have to go on the next step. Similarly, some kind of project which require rapid development. It means in sort of time we'll have to complete that project. We have only time of 2 months, and the project is very huge. So what software company will do, that will work on that project in multiple increments, in multiple teams, will follow the same process. So in simply we can understand by taking one example. We have an organization, and they have multiple departments. So what we will do, we will divide the module of different department to the different teams, and different teams will work on that different departments software modules, and at last we will combine that, we'll assemble that on the same place in a same package. So that model is known as rapid application development model. Similarly, spiral model. Here, multiple processes you are seeing. You can see here, parallel processing is going on, and whole process is divided in 4 phases: determine the objectives, identify and resolve risk, development and test, plan the next iteration. So we'll discuss in the actual lectures, but here we are seeing that model is different than that, and that model is different than that. And the next model is that which says that now software industry use the concept of reusability. Most of the modules are already available in the library, so no need to develop each and every module again and again. So once software industry start any new project, first of all they find out the similar kind of software which already developed in the company, and by using the modules of that software, they develop new software. So that concept will be discussed by component based software development model. So basically that model says the concept of reusability is very important in software industry to save the cost and effort, and also the time of software development. Here one thing is very important. We see that models are different. So why here models are different? What software is the simple thing? Software is a one thing. So the answer of that question is, as per the software, or as per the requirement of the customer, software industry will decide, software development team or software development team's manager or the management will decide what kind of model should we adopt, which we can develop that software with fully customized, and also in fast speed, by saving the cost, by saving the time. In short time, what kind of model will help us to develop that software? So as per the need, as per the software type, we choose the software model. And a wide variety of software models are available. This is just introduction. So we will continue on that lecture by detailed discussion on each of the topic like SDLC, and we will take each model in detail. Thank you.